Okay, so now that we have seen the code or analyzed the code of the smart bank and the code for the first three quests, we'll try to review the code for the fourth quest, which is launching your own coin. So let's get directly into the code for the coin. So here's the code. Now, see, one thing is you will notice this version 3 because this coin has the transfer. mm, uh, this coin has the functionality of depositing the commission amount whenever someone does a transfer. So it will, whenever someone transfers some amount, ERC20 tokens will take some amount of commission from the depositor or the transferer and will deposit that much commission into the deployer's account. So in that case, it will be us because we have created this currency. It will be the person who deployed this contract. So, you know, So what we have, to give you an overview, I have created for the fourth subquest an ERC20 token. So we have been using DAI up till now, right? DAI token. And for the fourth quest, I have created, or using the quest, I have created this ERC20 token of my own. So let's get into it. So you'll notice I have given Genius Coin version 3. I know, yeah, it is, you know, cringy name, but just run with it. So we have to pass the name of the token, the symbol of the token, and the not commission. We don't have to pass commission. So there's two things, name and symbol. I think it is to be compliant with ERC20 standard. We have to pass name and symbol. Okay. So that's this mm, uh, document where they have specified what you have to do or what you have to, how you have to structure your ERC20 token to make it compliant with the ERC20 standard, right? It is, I think, published by the Ethereum Foundation itself, I guess. Yeah. Yeah, you can check it out later. But let's get into the code again. We are storing the name and the symbol in name variable and symbol variable. And after that, uh, let's check the constructor. So when we deploy the contract, the constructor will be called. It will be called only one time when we deploy the contract, right? And what this will do is it will take the deployer of the contract, which is or the address of the deployer, which will be in message.sender, and it will pass or it will store that that address in deployer variable. So deployer variable is a variable of type address. We store the deployer address there, and after that, you know, uh, let me describe what this balances is. So it's basically a mapping from addresses to uint, that is address to amount, right? How much address or how much amount a particular address has, right? So in the constructor function, what we are doing is for the deployer itself, we are reserving this much amount of ERC20 tokens, right? Because we are the deployer, we are the contract creator, so we should get the initial amount of money, right? And we'll need it later on, right? So what we'll do is, and this amount is, see, in this case we have provided we have this token has only 8 decimals. So this DAI token that we are using and ether, both of those tokens have 18 decimals, but this token that we are coding has only 8 decimals, right? So what we are doing here is, this is 10 million. Is it 10? No, it's 1 million. So we are reserving 1 million and we are transferring or minting that 1 million for the deployer itself. But for, we are multiplying 1 million by 10 raised to 8 because our token has, 8 decimals. So that's what we are doing here. Okay, now that's done. Let's review these small functions. And we have this name function, which will basically just return the name of the token. This will return the symbol of the token, which is GCV3 in this case. And this decimal function will return the decimals. Yeah. And we have this total supply functions as well. So, there are two different kinds of ERC20 tokens. Some tokens, the first kind has, a limited supply, so a fixed supply, and some tokens have, unlimited supply, not unlimited, but the supply can be increased, I guess. Right. So I think, not I think, but Bitcoin is of the first kind. It has fixed supply. I think it is, I don't know, 21 million. I don't know. I don't remember. So Bitcoin is of first kind, fixed supply, and Ethereum is of second kind. Its supply can be increased, right? So that's that. And in our case, the ERC20 token that we are coding, we have kept it as fixed supply. So how much is the supply? It is 10 million. So this is the amount, 10 million. And again, we are multiplying it by 10 raised to 8 because we have 8 decimals, right? So there will only ever be 10 million tokens of this contract. There will ever be 10 million GCV3 tokens. All right. So this is what this total supply function returns. I mean, we should have just store this total supply in a variable of something, but because it's by definition a fixed supply token, we don't want to change the amount of supply. Hence, we don't want a variable, because variable implies that we want to change that amount. I mean, not always, but just to, explicitly say that this is a fixed supply. We're just storing it this way. All right, so that's that total supply. And again, we'll use this total supply for accounting purposes, because when we are trying to mint, so let's say the final mint, the total supply of the tokens don't increase this much, uh, don't increase more than this amount, right? Okay, that's that. After that, we have this balance of function, which returns the balance of that user. So in this case, suppose when we deploy this contract, we'll have, excuse me, so the deployer will have 1 billion tokens. So this will return 1 million, and it will directly return the amount multiplied by 8 because we are already storing it that way, right? Okay, so that's that balance of. After that, now comes the meat of the token, or the main functions. One of the main function is transfer function. Let's check if we have other function that we can check first. Nope, let's just get into the transfer function. Yeah, I'm trying to analyze the code in whole first, or maybe we can, after we have done the transfer, analyze the transfer function, we can check the execution as well. So I don't know. Yeah, let's try to do that. Let me compile this and let's try to interact with it first, and after that we'll check the code. I should have done this earlier, but anyway. Let's deploy it. And yeah, we don't want to deploy it to Ropsten or any test network. We'll just deploy it just locally in the remix environment, just for testing purposes. So let's check this getter functions that we had. Let's check the name, get the name, symbol, and the total supply, right? 10 million. And decimals, 8. Let's check the balance. So the token has the contract has been deployed. So, and in this case, this is the deployer, this account. So let's check the balance of the deployer itself. It should be 1 million, right? And here it is, 1 million. Okay. Yeah, so now let's try to call the transfer function. What we want to do is, we want to transfer some amount. We want to transfer the amount from this user to this user. Now, this user has not minted anything. So if we check the balance of this user, it should be 0, right? So we'll transfer some amount to that user. So for that, we'll call transfer function. So we have to pass the to address, which will be this address. All right, we copied it and we'll transfer. First, we'll select the first address from which we are going to transfer. And we're going to transfer, I don't know. Okay, we'll have to convert it into 8 decimals as well. Okay, so this first user or the deployer has 1 million, right? So I don't know, 10,000. Let's try to transfer 10,000 or 1,000. 1,000, but we want the 1,000 in 8 decimals. So let's use this. Let me write 1,000 and let's convert it into 8 decimals. Okay, let's copy this value back to this value. So after the transaction is done, this address, the second address, let me recheck. We have selected the correct address. We have selected the first account, which is the deployer, which has 1 million token. And after the transfer, this let's check how much balance the account that we are transferring to gets after the transfer. Let's transact. Transaction has been done. Let's check the balance. Okay, he or she has got 1 million. Great. Right? Oh, sorry, not 1 million. This much amount, which is 1,000 GCV3 tokens. And if we check the balance of the deployer from which we transfer, it should have gone down, right? Let's check. Yeah, it has gone down. So the accounting has been taken care of. Now you will notice something, but we'll explain it later. So let's get into the code, right? And when we call this transfer function, we have to pass to and the value that we want to transfer. And first we check this if the to is not a null address, so that we don't accidentally burn the amount, that much amount, because if someone accidentally sends the amount to a null address, this is basically a null address, 00000. That means that much amount is lost forever. No one can retrieve it back. So for that to not happen, we have this check in place. And after that, we have another check. If the to address is null, it will revert back the amount. Okay, so let's check the require balances message on sender. So the sender or the from or the transferer or whatever should have the value that they want to transfer plus this commission. So as I pointed out earlier, you might notice that we have this commission, right? So what is this here for? See, in the quest, if you go through the quest as it is, you won't have to do this commission accounting stuff, but it is part of one of the challenges of the quest. It's just a minor code change, so I have kept it here, and I have decided to just analyze the code with the commission included as well. So if we were to code an ERC20 token without the commission, this won't be here, the commission. But so let me tell you what commission here is, right? So whenever someone transfers some amount from, so let's say there are two people, uh, Bob and Alice, right? Bob wants to transfer 10,000, I don't know, 10,000 GCV3 tokens to Alice. So what here it will happen is when Bob calls transfer function, it will transfer 10,000 GCV3 token into Alice's account. But on top of that, this transfer function will also take some amount of commission, this commission amount from the transfer. So in this case it will be Bob who's the transfer. So Bob will not only spend value that he or she is transferring, so in this case 10,000 GCV3, but he will also spend the commission as well. The commission will be taken from his account for that. And how much is commission? Let's check. We have thousand way or whatever, it is like 0.0000 4 times 0 and 1000 GCV3. So that much amount of GCV3 token we take as a commission for transferring. And where does this commission goes? It goes to the deployer, the contract owner. In this case it will be us. Okay, and yeah, so for that we have this check into place, that we check if the transferer has value plus commission amount, at least that much amount of balance, or else the transaction should not be successful. All right, so after that we have, so after that what we do is we take the value plus the commission and we deduct that much amount from the sender, and we add the commission to the deployer as well, and we add the value that the transferer wants to transfer to the receiver, right? So in this case it is in two variable _2. So we deposit that much value in that account, and that's it. That's the basic accounting of transfer. And after that we have this transfer event that we are calling, that is basically to comply with the ERC20 token standard. We have to emit this event whenever someone transfers. So we'll emit this transfer event and we'll pass the sender the to and the value, from to and value, and we'll return true because the transaction was successful. So that's it for the transfer. And see, you might notice that when we transferred from from this first account to the second account, this 1000 GCV3 got deposited in second account, but in the first account that much amount only got deducted, right? While in this case it should deduct the commission as well. So how is it possible? Where's the commission deduction? Well, it is because in this case the first account is the deployer itself. So what we are doing is first we are deducting the value plus the commission, and we are again, because in this case the deployer is the message.sender itself, so we are taking out a commission from the deployer of message.sender and again adding that commission back. So that's why it's like this. But let's check the another scenario when let's say now this second account. The second account has this one. Let's copy this. The second account has 1000 GCV3, right? So let's transfer, I don't know, let's try to transfer the whole 1000 GCV3 to the third account. Let's see what happens. Copy the address and let's call the transfer. Okay, we have got the correct address, right? We are transferring 10,000 GCV3, and let's check. Let's select the second account, which has this much amount of token, right? 10,000 tokens. Here you can see this account has 1000 tokens, so we are going to transact. Let's see what happens. Oops, it failed. And if we check the log, it is saying that not enough balance. Why? Because although we have the value amount that we want to transfer, we don't have the commission amount, right? Because we only have that much. So let's do one thing. Copy this minus the commission. How much is it? Okay, let's try to transfer this much amount and let's see what happens. Okay, not this one. Yeah, this one. This should go through, right? Let's check. Okay, so that was successful. Let's check the balance of the second account now. It's 0 because we transferred the we transfer only this much amount, right? But that second account had 1000 GCV3. So where did the other money go? How much? The commission amount. Yeah, so the commission amount should have gone to the deployer, right? Let's check the balance of the third 2 account. It should have this much amount of tokens, right? Yeah, but if we check the balance of this, the deployer itself, you will notice that the amount has increased by 1000 because we got the commission, our first commission from second account for the transfer. So yeah, the transfer functionality works. So that's that. And after that, we have a similar function, transfer form. Okay, and transfer form function. So the difference between transfer and transfer form is basically in transfer form, we are passing from function explicitly. Now this function is being used when you approve. So in our bank's case, when we try to approve the DAI token and approve the DAI token this contract, and this contract try to transfer the token from our account to their account, right? So for that to happen, we have to have this approve function as well, and this transfer function will be called by the approved party, the spender. And in that case, we can't just use message.sender because message.sender is the spender, SPENDER, spender itself. But in the money that we want to transfer from the account that we want to transfer the money from is a different account. So for that, we have this transfer form. We can't just use transfer because we are just using message.sender here. And all of the checks are basically same as transfer function. The only thing different is instead of message.sender, we have dash from. And again, this check is same. We already saw it here and this as well. So the only thing different is this from. In this case, we had message.sender. And now we will notice this function. So as I already told you, when this function is what will be called, this will be called. So think of it like having 3 parties, right? There's the first party, second party, third party. So let's say, I don't know, Bob, Alice, and John. So Bob, Alice, and John. John is, let's say, a smart contract, not even a person. And Bob wants to approve this smart contract. John, let's just call it John, because why the hell not? So Bob wants to approve John, that the Bob wants to approve John some amount of money from Bob's account that John can spend. So first, Bob will approve some amount to John. Now John, once the amount has been approved, now John can do the transfer with that function. Do anything that John wants to do. Right? It can transfer the function to itself, or transfer the amount to itself, or it can transfer the amount to any other party. All right. So that's that. So for that, we have this approve function. Let's just check the approve function first. Yeah. Right. So in approve function, we are passing the spender and the value that we want to approve, and the spender, and this approve function will be called by the owner itself. So suppose I am the owner and I have 10,000 tokens or money, 10,000 GCV3 or whatever, and I want to approve, let's say, 1,000 GCV3 to some other smart contract. So what I will do is I will call the approve function. I will pass that smart contract's address in spender, and the value will be 1,000 GCV3 here, right? So basically I'm trying to approve that much amount to the smart contract. So what you know what, let's try to, instead of describing the flow, let's try to see it in action. So this, what we'll do is we have this 3 accounts. Okay, one function, one account, this account. Let's take the balance of the deployer itself. It is this much, right? So now we'll approve 1,000, not 1,000, let's say 10,000. We'll try to approve 10,000 GCV3 to some other account. So this account doesn't have anything, right? Yeah. So we'll approve this account. How much? This will be the spender. How much? 10,000, right? So let's convert 10,000 into GCV3 tokens. 10,000 into 10 raised to 8. Let's copy it. And before we call this, we need to change it back to this, because see, this is the message dot sender, the owner, and the owner is calling approve, telling the contract to approve this second account, which will be the spender. Will approve 10,000 amount of GCV3 to this account, and let's do that. Okay, it's been done. So now we have this allowance function, right? This allowance function will basically return us back the allowed amount that the particular spender has been allowed or approved of by the particular owner. So for that, we will have to pass the owner and the spender. So in this case, yeah, this is the spender. Second account is the spender. This first account is the approver, right? Or the owner. So owner and spender. Let's check how much this owner has approved this spender. And yay, this owner has approved 10,000 GCV3. Great. So now that we have the approval, let's change back to the second account, which has the approval. And the approved account will try to use this transfer from function to transfer the 10,000 amount from this to this, right? So let's see. Where's the transfer form? Here it is. What did we just copy? Yeah. Okay. I need to copy the owner. So this is the owner. Second, third one will be the let's just send it to the fourth account. Fourth account will be the receiver. And how much was the amount? Yes. Now, if you remember that uh, the some commission will be transferred, need to have some commission, the value that we are going to transfer plus some commission. But in this case, the from, which is from where we are deducting the value, has, he's the deployer, or he or she is the deployer, right? So they have like 1 million. I don't know, now we took out some, but yeah, close to 1 million tokens. So they have the commission. So when we try to transfer this much, transfer from the owner to this account, fourth account, let's see what happens. And yeah, it was done. And after this transfer form, if we try to check the allowance again, it will be 0. Why? Because we spent all of the money that we were approved of. And now if we check the balance of the receiver itself, it should be this much, the transferred amount, and the spender or the owner, it should have gone down. Yay, it went down 98 and something. All right, so that's that. There it is, transfer form and approve. So yeah, so now that we have checked the flow, let's check the code as well. We have this approve, we pass the spender and the value, and we are storing the allowances in this mapping. Allowances, it is a kind of two level mapping. So at the top we have the owner, and owner can have many spenders. So owner can approve different amounts to different spenders, and these spenders can be approved of different amount from different owners. So that is kind of a many to many relationship here, right? But in one particular shell, we are saving the value, the allowed value, right? Method dot sender, unknown owner, and the spender in the value. And again, for the for being compliant with ERC20 standard, we have to call this or emit this event approval. Yeah, for that we pass this owner and the spender and the value, and we return true. There's not much to approve. And for allowances, to get back the allowance, what we are just checking the allowances, returning the owner and the spender. That's it, nothing much there. And after that, okay, we didn't complete transfer form, right? So here we are checking that from the owner from which we are transferring the amount, and the spender, in this case it will be the contract or the person calling this transfer form, has the allowance or not for spending that money from this owner's account. So this allowance should be greater than value, right? Because if we are trying to transfer 10,000 GCV3, we should have the approval of that much amount. So that's this check for that. Excuse me. After that, we do the same accounting stuff. We deduct from the main transfer account the value plus the commission, and in the deployer account we transfer the commission amount, and to account in the receiver account we add the value. And after that we have this another accounting step. We deduct that much allowed value, because we have all, suppose I have been approved of 10,000 GCV3. Then after spending that much GCV3, my allowances should go down, right? So there's this step for that. After that, again, to be compliant with ERC20, we have to emit this function transfer. There's that, and it's the same emit same event transfer. The difference is this: in this case it was message.sender, in this case it is from, and that's that true. Okay, so that's the basic functionality, and on top of that we have this extra functionality as well to mine this. So what this logic does is, there's this mine function, and there's this specific condition that if the block number, that particular block number is a multiple of 10, right? If that block is a multiple of 10, then we'll allow a single account to mine, uh, to mint some token, right? And it can be the tokens can be minted only once for per 10th block, right? So once someone mints the token, then we have to turn it off for other users. So now if someone has minted, we shouldn't allow any other person to mint it again. So for that, we are keeping track of it in this block mined array. It is, oh wait, what is it? Yeah, so it is a mapping, sorry, it is a mapping of uint to bool. And uint is the block number and bool is the status, that if that block has been mined or not. So when we call this mine function, first we check if that particular block, that the current block is mined or not, and if it has been mined, so this will return to that. In that case, we should return false. We shouldn't go ahead with minting. But if that block has not been minted, then again we have this another condition. For minting to occur, that block should be a multiple of 10, right? So we have this formula to get to check if it is a multiple of 10. We have this modulo operator, and we divide it by 10, and this modulo operator, the result will be the remainder of the division by 10. If it is 0, that means it is a 10th block. If it is not 0, then it's not a 10th block, so we should return false. And if it is a 10th block and it won't go inside this, it will continue the calculation. After that, we have this check in place. What does it do? So remember, we have this total supply function. Remember I told you that this token, ERC20 token that we have coded, has fixed supply. So now we don't want the supply to increase, right? So see, the blocks can go on, it can go up to infinity, but we want to stop the mining, this mining function, when we have exceeded the total supply. We don't want to mint any more amount. So for that, we have this check into place, and we have this total minted. So in total minted, we already have this hard coded value. Why? Because if you remember, in the constructor we minted 1 million token for ourselves, or the deployer, right? So for that, we have total minted amount is equal to this much initially into 10 raised to 18, of course. And yeah, so when someone tries to mine the block, we want to check that total minted, so the amount that has been minted already, plus the reward that the miner will be getting, is less than total supply or not. see, in this case it should be like less than or equal to, but yeah, it doesn't matter because we want the exact supply. So if in this case it is 10,000, 10,000, right? So this should be 10,000. Yeah, so it should be equal to, or else the last block won't be last 10 this much amount. How much is it? 10 GCV3 tokens won't be minted. It will be burned, I guess. Or yeah, because if we try to mint the last 10,000, it won't be less than total supply. It will be exactly equal to total supply, right? If I am correct. Yeah. So this should be equal to. But yeah, if the total minted has plus this much is already exceeded total supply, then we won't mint any more tokens. But if it has not exceeded the supply, then we will again continue. So we have these three checks before we mint or mine. So if the three checks passes, then what we'll do is the person who is calling the mine function, who has uh, passed all these three checks, will get this much reward, or this much tokens will be minted in their account. So their account's balance will increase by 10 GCV3, right? And after that, we'll also increment total minted by 10 GCV3, and after that we'll make this block as mined, because we don't want another function to call this mine function again for that particular block, because it has been minted by one person already. So we change the status of that particular block, right? And we pass true. So yeah, let's try to mine it. For that we have to get the current block first. What is the current block? It is 10, it is 6, right? So it is 6. So what happens if we call the mine function? Where is it? Mine, yeah, it's here. Let's see what happens when we call mine. You will notice this variable success equal to false, because we are returning false here, right? As the return value of success variable. Because why it failed, or why it was a failure, or we were not able to mint, because the block number is 6, right? Which is not a multiple of 10. So let's try to find a multiple of 10. Okay, let's try to find. For that, I think we need to do some transaction or something. After that, yeah, we need to do the transaction. Yeah, let's call the mine function. Then it will change. We'll have to change the state. You can't just read, right? 8. Let's call mine again. Get current block 9, mine again. It should be now 10, right? So let's first check is mine function. We'll pass 10 block number, and it will return false because it has not been mined. So now we can mine this function. So let's try to call mine. And you know what we'll do? Let's try to mine it with this fifth account. 1, 2, 3, 4, 5. And first, before we mine, let's check the balance. It is 0, and the current block is still 10, right? So now if we mine this, and we can get the total supply. No, that is the total supply. Yeah, so if I mine this now, and if I check is mined, it should be true now because it has been mined. And if you check is mine function's return value, it's this one. It should be true now because it was the multiple of 10, it was not mined, as well as it was a multiple of 10. It was basically 10, and the total minted value is less than total supply, so it passes all three checks. Therefore, this user should have this much 10 GCV3. Let's check. And as you can see, this user has got a reward, mining reward. All right, so with that, I think we have reviewed the code for Genius Coin as well. Sorry. Now, as I promised you earlier, let's try to use this ERC20 token in our bank, right? And for that, first to do the transactions and all of those kind of stuff, first we have to provide the liquidity and all of those kind of things. So I think I have already gone ahead and deployed some of the tokens. As you can see, I have deployed a whole lot of tokens: GCV3, V2, GC. So first we'll try to use this. So I'm not going to deploy a new token contract and do the add the liquidity and all of those kind of stuff, because I already done it. So I'm just going to use these tokens, right? So you can see there are 4 tokens, but we are concerned with only this second token, GC and this third token, GCV3, right? So this GC is the token without the commission, right? And GCV3 is with the commission. Now we can check the contract as well. I think let's check the contract if I have published it. Let's view it on Etherscan. Have I verified it? Okay, where's the contract? Yeah, I have already verified it. Let's check the contract. That's not much difference from the code that we saw. I have just this, instead of checking value plus commission, I'm just checking value, and I'm not even subtracting the commission. Basically, I don't even have commission variable, right? So it's the token without commission, and then ignore this comments. I have deployed this coin when I was testing it, and I didn't took out this comments, whatever. And this is my earlier attempts of doing the commission stuff. Before I was trying to take out 10% from the transfer, but I thought it won't be that much good. So then I hard coded the commission value as just 1,000. Okay. So yeah, let's try to use this coin, GC coin. So what I will do is, first let's copy this. So it is an ERC20 token. I'm not going to go through the whole thing, but let's just add a balance in GC coins, right? So let's see. Or yeah, let's try to do that. For that, let's first check the balance is 0. Okay, yeah, it's all 0. Yeah, okay. At the balance of C. Now the balance from the account from where I will be adding GC tokens already have this much GC token 986, because this is the account that I used for deploying, right? And as we already saw, we have 1 million in the name of the deployer, and I already spent some amount Yeah, so let's do that. Let's add, did I copy? Oh yeah, I need to copy this ERC20 token. Let's add ERC20 token, that much ERC20 token, right? Okay, so if you remember, we need to approve this contract first for of that much amount of balance, right? So for that we'll use this. Okay, I need to go into contract and we'll call the approve function, right? So I already copied the, let's check the allowance first of for this contract for our genius coin. Allowance for the genius coin, I have 0 allowance. But now if I connect to web3, and I have to call approve, for that I need the spender, and spender will be, okay, it will be this, the contract itself will be the spender. And you know what, let's just give, I don't know, 1000 GCV3. This 10⁸8, right? Let's allow this much amount of token for approval. Let's wait for the confirmation. Meanwhile, let me copy this address and need it again. Let's check the allowance. I think we already have it. Yeah, we have it here. It's still, oh yeah, we got it. So it was successful. So now our contract, this is, something amazing. We have created our own ERC20 token and we are using that ERC20 token in our own bank. That's amazing. So we have got this much allowance now and we can spend that much. So we'll pass this and we'll add that much amount of ERC20. So let's check the token balance of our account. It is 986690, right? And we have allowed 1000 GCVC. So after the add balance call, this should go down to 985690, right? So let's call this. Okay. Okay, it was successful. Let's check the GC. Okay, it has gone down by 1000 GC. And if we check the balance, ooh, we are getting ether. Why? Because we have already, just like we have coded, we already swapped those tokens for ether. Great. Now we can get the ether for that much amount that we deposited. Let's get that. We have already seen that, So let's get, just for the functionality itself, let's just withdraw the balance in that much tokens only. I think this might fail. Let's see. Where is withdraw ERC20 max? Let's see if this passes or fail. Okay, let's see what happens. Oh, yeah. So basically, we should get 10,000 GC back if this is successful. 95690. It should be 98690 if it was transferred successfully, and 986685. Now, why is that? Because when we deploy to, or when we deposit to compound, there's some amount that's being lost, right? I don't know why I have not checked into docs that much, but we are not getting the whole 1,000 tokens. We have got we some amount have been has been detected, but this means that the functionality is working. The ERC token that we have created can now be used in the transaction. You know, yeah, but for that we have to already provide the liquidity, and I think we already have it well documented in the quest itself. I won't go into it. This was just me, you know, going through this code. Yeah, that's that. So yeah, this is it. You know, I have completed the first quest, the whole quest. So there you go. And that's it. And yeah, so to announce it again, this is not part of the series that I'm doing on the channel, and I will be doing mostly probably in depth, or I think I already did the in depth explanation, did I not? Right? Maybe, I don't know. Maybe I will explain it again. Maybe this can be just a expansion of the series. I don't know. Let's see what happens. But yeah, I have completed the whole quest. That's it. And I will see you guys in the next video. Thanks for watching or listening. If you watched until now, it's been, I don't know how much hours, more than hour. Alright then. Yeah, bye bye. Thanks for watching. Subscribe to my channel. Bye.